Today we will discuss about the EKS. What is EKS? Kubernetes service. This is also very important. Elastic Kubernetes services. So how to create the cluster in the Kubernetes, how to deploy the application in the Kubernetes services, how to deploy the pods, nodes. Okay, so just click on Kubernetes services. So before that, select the region before you deploying the Kubernetes services. Yeah, go and select the region. I'm selecting the Mumbai region. So my first region is already filled with the cluster. Okay, so just a minute. We start regarding also, right? See, so ECS. So click on ECS. Is there any clusters in ECS? Last class we discussed about the ECS clusters. Click on EKS, Elastic Kubernetes Services. Yeah, these clusters are there. There is no clusters. For Kubernetes service. Imagine EKS, so Kubernetes service. Already have one cluster. Yeah. So before creating cluster, let's open another tab. Back into this one also. Select Mumbai region. Yes. And go for EC instance. Yes. Yeah. This we have few instances are running already here. Right. It's okay. Right. Okay. So now I want to create the one cluster by using the EKS, Elastic Kubernetes Services. So add cluster here. So create cluster. Use the cluster name. My cluster name is simply I'm giving what cluster, and then Kubernetes version. So we have this so Kubernetes engines. So we have 1.17 engine, 1.18 engine, 1.19 engine, 1.20 engine. Yeah. So I'm taking the latest one. 1.21 is the recent to Kubernetes engine. I'm selecting. Customer service role. So in, last time we discussed, right, IAM management. So we can create the groups, users, roles, and right role we can create here. So I want to create one role. I will attach that role to my cluster. So this is my cluster name. This is my Kubernetes engine. I want to create one IAM role. I will attach that role to this cluster. So how to create? Just click on this IAM console. Now you can create the new role and you can add that role to cluster. I will show you how to create the IAM role. Once you click on the IAM management console, yeah, create a role. See, we have a number of options are available. Select AWS services. Now you can see EC2, Lambda, and below you can see our concept EKS. I want the role to allow the EKS permissions. Select the EKS. EKS means Elastic Kubernetes Services. So EKS cluster role I want. Allow access to other AWS service resources that are required to operate a cluster managed by the EKS. This role I want to do. Select EKS role, cluster role, click. Yeah, this policy I attached to imagine EKS cluster policy. Click next, click next. So give the role name. So hello world cluster role 9. Hello world cluster role 9. I'm doing like that. It's already there. I'm giving like that. This is my role name. Create role. I just create one role. I will attach that role to my EKS cluster. Yeah, role is successfully created. So the job of the role means this role allow the cluster to manage your worker nodes. Yeah. So this is the cluster name. This is the Kubernetes engine. So here refresh, just refresh. If you click on drop down, you can see you recently created. This is my hello world cluster role 888. So this is my role. I selected the role. So these are all default settings. Click next. Now you can see select your VPC, virtual private cloud. You have some other custom VPC also. If you create your custom VPC, you can select also. Otherwise, you can select default VPC. You can see VPC with my subnet 172.31.0.0. Under this network, I am creating cluster. Under this VPC, I am creating my cluster. So these are the zones. So zone A, zone B, zone C. I added all the 3 zones. And you can else your security groups also. You can leave it blank also. Later you can else. So I already EKS cluster security group I added. Next, cluster endpoint access. Configure the access to your Kubernetes API server endpoint. So if you want to connect to your cluster, so you public access, you provide the public access from your local machines, so you can connect to your cluster. By using your Linux machine or Windows machine, you can connect to your cluster if you public access. Private public as possible. If you do private, you are unable to connect. So from outside, we are unable to connect. For internal people only able to connect to your cluster. Okay, right now I'm selecting the public. So network adds, these are all default settings only. Click next. Yeah, config login. These are the control panel. So see, last time I shared one guide, right? That is a real-time my organization guide. So then that guide you can see Kubernetes architecture. So we have one master node and worker node. Master node is control the worker nodes. So master node have the 4 components, major 4 components. You should remember the 4 components: ECTD, API server, cluster management, and scheduler. So these 4 components will control the worker nodes. In the worker nodes, we are deploying our containers, right? Yeah. So worker node is nothing but instant, one computer, one machine. In that node, we are deploying our application in the form of the pods. Pod is nothing but our application, smallest application. Okay. So these are the chargeable things. So if you require, we can enable. Otherwise, you can leave it as default. Yeah. Click next. So this is the cluster information. Yeah, everything's fine. Just click create a cluster. So yeah, so my hello world cluster is created. So this is my cluster name. See, it will take time to 10 to 15 minutes to create your cluster. Your cluster is start creating. Once cluster created, you can see overview of the cluster, workload information, configuration. Under configuration, you can see compute. Under compute, you can create your node groups. Serverless technology Fargate. You can enable the Fargate profile. Also, you can create the node group. You can add node group. You add Fargate profile. So this is the server-based cluster. This is the serverless cluster. You can use the Fargate technology. Otherwise, you can use the node group technology. So node is nothing but one instant, one computer. So that computer. So cluster is nothing but collection of the nodes, collection of the computers. Under computers, we are deploying our container image, right? So it start creating your cluster. Just refresh. Yeah. So once creating cluster, go client side. If you are using the Windows system, so you can use Windows system via Windows system PowerShell. You can connect to your cluster. That is one method. By Linux system, by using Linux system also, you can connect to your cluster. To connect to your cluster in AWS Cloud, so what are the instructions? For example, so this is my system. So connect to your any. This is maybe, let's see, this may be Amazon Linux or Ubuntu, whatever maybe. So just launch one Linux computer. After launching the Linux computer, you need to install few softwares to connect to your cluster. Let's test this to present working directory. Yeah. So this is the Amazon Linux. So who am I? Username EC2 user that ls get right. So in this you have to install the 2 software. So one is the AWS version, AWS version. AWS CLI already installed, right? Next, so you need to check the Docker install Docker version. See, Docker also installed. Okay. Next, we need to install the kubectl. Kubectl. See, if you install kubectl, it will look like. So next, how to install kubectl in your Linux computer? So this is the commands we can use to install your kubectl. Just open another tab. So I will give you the steps to install the kubectl. So Elastic Kubernetes service in AWS. This type. Yeah. So yes, EKS in AWS. It will open the official document, so you can see all the steps how to configure, how to install the kubectl commands to connect to your cluster. Yeah, Amazon EKS. Yeah. So this is the AWS official document. So from here you can see the how to install the kubectl. Right. So you can see cluster management. Expand the cluster management, install kubectl. So these are steps to install kubectl. You can install kubectl in your Mac OS, And Linux, in case your base computer is Linux, these are the processor. In case your base computer you are using Windows, so via Windows also you can connect it to your cluster and you can control your worker nodes. Right now I am using the Linux computer in AWS dashboard. So in the AWS dashboard, if you are using Linux computer, these are the command. So the Kubernetes cluster, this is the version I used. I installed the Kubernetes version 1.21. So this is the command to install the kubectl. So copy this command and go for your EC2, copy paste here. Now it will be downloaded. kubectl software will be downloaded. This is step 1. Yeah. Next command, step 2. We have 4 to 5 steps here. We need to follow one by one. Check the algorithm. Step 2. Yeah, this one optional. Verify downloaded binary with the SH25 some word binary. I install my kubectl engine, cluster engine 1.21. This is command. Select second command and enter. One by one. Yeah, algorithm also verified and see. In second step, below you can see option B. Click this algorithm verification. SH algorithm enable or not? Yes, yes, it is enable. Next, come down. This step 3 give the permission to kubectl to connect to your cluster. chmod means so you are giving the permissions, yeah, to your kubectl software. Yes, permissions provided. Execution permission I have provided. Right. Step 4, set the path. Copy this one. Enter this one. Set the path. Yeah, path set. Next, step 5, verify the path. Yes, variable path. So that one also set. Like the step 6, check the kubectl version, successfully installed or not. Step 6, yeah. So kubectl version short client. See, kubectl version v1.21.2. So version successfully installed. So these 3 software you have to install before connecting to your cluster. Now after installing kubectl, just you can click ls, it will display. So kubectl algorithm, these 2, one is directory, one file will be displayed here. Okay, so kubectl successfully installed. If you enter this command, it will look like so. kubectl, see, it will come like this. That means kubectl is successfully installed. So by using this kubectl, you can connect it to your AWS EKS cluster, and then from your local system to you can manage your cluster and your worker nodes also. Let's see. See, so it is cluster is created now. Let's refresh. So once cluster created, we can establish connection to your cluster. How to establish connection to your cluster by using your local Linux computer? We have a few commands. I will show you the commands. EKS. Document. Yes. So this is the doc command. Let's open. Right. Close this one. Right. Right. So let's see. So for cluster created, we can establish the connection. Refresh. It's still creating stage only. It will take a minimum 10 to 15 minutes. You need to wait. So main advantage of cluster means disaster recovery and continuous application availability, productivity anywhere. So once you deploy your any application in cluster, so one or two nodes down is not a problem. So we can manage it with other nodes as well as. So that much flexibility is there with the cluster management. So in the cluster, we can create a cluster with a number of the nodes. You can take 4 nodes or 5 nodes or 6 nodes. So based on your requirement, you can take a maximum number of nodes and you can run your application on that node worker nodes. Automatically, cluster will manage all the nodes. In case one node is down, automatically cluster will manage that nodes. It will again come back to upstage. Meanwhile, other nodes will manage your application like that. So that is main advantage of the cluster. Instead of directly running into one single computer or one direct virtual machine, you are running your application. that place you are running the applications cluster. There is very advantage to the customer side. Application will be available 24/7, anytime, anywhere, any place they can able to access without any interruption, downtime. SLA also increases. SLA timings also increases. Let's see. So start creating the cluster. So once create cluster, so these are the commands to connect to your cluster. Let's see the commands to cluster. These two commands you need to enter, right? This is the command. So EKS AP South region cluster allow cluster name. This is command you need to enter your Linux computer. Copy this command. Go for your Linux computer and then enter this command. Yes, copy paste. Yeah, cluster still creating. Once creating, it show active. Again, enter this command. These two commands allow your kubectl to connect to cluster in AWS. After connecting, now you can check the node status. Add a new context. So add this one. Yes. Enter this one. See. Active. See, cluster is created. Active means cluster is created. Now go and check cluster is created or not. Yes, refresh. See, cluster is active here. Active means cluster is created. Now my cluster ready. So I connected to my cluster. Okay. So after connecting to cluster, you can check the cluster kubectl get svc service status. Just click on this command. Yeah, my cluster ready. Cluster IP address is display. Cluster is ready. So what about nodes? So is there any nodes created? No, we are not at created worker nodes. Now I will show you how to create the worker nodes in your cluster. After creating worker nodes, you can deploy your any application. See, no resource found. That means worker nodes not yet created. Now go and create the worker nodes. Yeah, step 1, cluster is created successfully. Step 2, we are by Linux computer, we are connected to our cluster successfully. Cluster created from your local machine to you are connected to your cluster. So step 1, step 2 done. Step 3, how to create the worker nodes. So go to your cluster. So this is my cluster name, hello world cluster. It is active, version is 1.21. Just click on this cluster. I want to create the node group. So here details tab, compute tab, network tab, authentication tab. These are all the options there. Select compute. Under compute you can see. So no node groups are there. This cluster doesn't have any node groups. Node that not part of the Amazon EKS managed nodes group. So not showing the AWS console. Now add the node group. Click add node group. Node group name. So I am adding the node group. Hello world cluster node. This is my node group. Hello world cluster node. So per node group also we need to provide the IAM role. So role means we are for this node group you are giving the access permissions. So just click on IAM again. IAM console. Yeah, create one IAM role per node group as well. Cluster we have created one IAM role. And node group also we need to create one IAM role. Create role. So at this time, so we need to give the 3 policies. Select EC2 instance. Click next permissions. What are 3 policies? I will show. These are the 3 policies you need to provide. Imagine CN policy, Imagine worker node policy, and EC2 container policy. Select first policy. Copy paste here. Go over here. Yes. Okay. This policy, select this policy. Again, second, select second policy, copy paste, go for your cluster. Yes, again, second policy, select second policy as well as, and then third policy. These 3 policy we need to attach to the our node group. Yeah, copy this third policy. Yes, attach this policy. Right. Next tag, view tag. Yeah, role name. So my role name is cluster allow cluster beginning any name. Hello what? Hello what? Already node groups that cluster node role triplet. This came like that. Create. I just create one role. I will add that role to my node group. a role created. So go just refresh here. After refreshing, click on drop down. Your newly created role will display here. This is my newly created role, cluster node group role. Yeah, select that one. Remaining all are default options only. Click next. Yeah. So what in node means computer. Which computer you want? Which type of computer? Linux with some specifications. So this is the first option I'm selecting. Capacity type. So which type of instant you want? On-demand instant or spot instant? On-demand is will be charged one type of charging will available. Spot is one type of pricing. There is pricing variation between the on-demand and spot instance based on your requirement. If in emergency, you can deploy spot instance. Okay, on-demand you can declare on-demand also. I selected default one. Instant type. So under microprocessor size. See by default T2.media. If you want to increase your node capacity, T2.x to large. These are the microprocessor capacity or small. So based on the instant type, charge will be applicable, right? So this is medium. If you increase the capacity, charge will increase. Hard disk size by default 20 GB. If you want to increase to 200 GB also, you can increase. It's not a problem. Charge will applicable. So this is the node group with the minimum 2 nodes. 2 nodes means 2 computers it will create. If you want to increase the number of nodes, yes, you can go increase 4 nodes. If you want 4 nodes, you can click on 4 nodes. 4 nodes will be the cluster with 4 nodes. So I'm creating cluster with 4 nodes, minimum 2 nodes. So maximum you can give any number, right? So click next. So these are the subnets. So I'm creating my nodes on all the 3 subnets. It will take any subnet. So in any subnet, my node will be launched. Click next. So this is node group. Yeah, these are the value. Click create. I successfully created the one node group as well as in the cluster. See, node group creation is in process. Okay. Now go and enter this command, verification command. So kubectl get nodes in your Linux computer local machine. Now it will display nodes are created or not. If you ready or not. If created, it will show ready. If not created, it will show not ready. It will show like that. Kubectl get nodes www watch. So it will take time because it start creating, right? So it is taking, it's waiting to give up output. So just wait. kubectl get nodes watch. So still creating. This refresh. Refresh. So repeat the command. Control C. Again enter the same command. Yeah, once nodes created, it will display here. Yeah, see, not ready means still creating. So once created, it will display ready. It will come like that. I created 4 nodes. See, it will display 4 nodes. Not ready, still creating. Yes, wait. Not ready. At sometimes it will ready. Once nodes ready, you can deploy your applications, your container. Directly you can deploy any container. Yeah, ready. See, control C. Now enter the command. So how many nodes you created, you can see also. This is command to check the number of nodes. Kubectl get nodes. See. Right now, I activated the 4 nodes, node group with the 4 nodes. 4 computers are ready. Now you can deploy your application on this node group. Your application will run all the nodes. So 1 node down, automatically your application available on the remaining 3 nodes. 2 nodes down also your application will. 3 nodes down also your application ready. Meanwhile, another node will be activated. So 1 node is down by mistakenly. Okay, 3 nodes are running. So we cluster will manage that to repair that node. So meanwhile, 3 nodes are running. So without disturbing the service. So once the first node is down, repairing the node will take some time. Again, it will be activated. Remaining nodes will be active like that. So like that, we can manage our applications in the cluster. See, my cluster is created. I created my cluster. Yeah. So with the latest Kubernetes version, click cluster. See, this is my hello world cluster. Yeah, I successfully created a cluster with cluster EKS cluster policy. After creating cluster, just log into cluster, select compute. Under my compute, I created worker node group also. So this is my node group. You can add number of node groups also. You add one more node group also. So this is the these are Linux based node group. If you want to add Windows based node groups also, you can add. So click on node groups. Node group capacity 4 nodes. Click on node group. Now you can see the number of nodes. So how many number of nodes you are running. So you click on nodes. You can see. I'm running right now. 4 nodes are running. This nodes capacity T2 that microprocessor capacity. Okay, node group name 2 minutes ago. All are ready. If it is down, it will show red mark. Failure down. Right. So you can see the health issues. There is no health issues. Kubernetes labels. Okay. Update config, everything is good. kubectl trinity, okay. Update is everything is fine. So nodes are successful running. So we created a cluster. We create one node group and we connected to our cluster via your local machine. It may be Windows or Linux. So right now I am showing how to connect to your cluster via Linux machine. I connected. In Linux computer, you have to install the AWS CLI, Docker software, and the kubectl commands. So once you enter these softwares, you can connect it to your cluster by using the 2 commands. These are 2 commands to connect to cluster. So if you based on your region, you need to change this information. I selected AP South 1. If you can say US East 1 or US East 2. Based on your region, you need to change the region and you need to change your cluster name. The 2 things you can edit. Okay. So yeah, this I will ping in chat. So this is command you can. Short, you can copy paste your notepad. Okay. Yes. Verification commands and connectivity commands. Right. Next, I want to deploy one application. How to deploy application in your cluster? Let's see. Go for your GitHub repository. In repository, you already implemented one project. So log into GitHub. GitHub. Just a minute. GitHub. Sign into GitHub account. Yeah. So once log into scope or sample project, node have. Yeah. The Kubernetes. This is sample repository. I will ping this repository. So this repository you can take any repository. Just sample I am explaining. This is a public repository someone created. I am using that one. Yeah. So log into this repository. Just click on pods. I want to deploy one pod. See Kubernetes pod commands. So creating a pod. So this is syntax to create the pod. Here you can use image version. This is the image location. You can use any image. This place you can replace your image, your Kubernetes EKS Elastic Kubernetes container registry. From where you can select your private image. You can paste here. Your public image you can paste here. It will copy paste the data from that image. This is a command to deploy your images. You deploy your container into the cluster. So copy paste this command and go and enter this here. See kubectl create -f HTTP. So it will deploy the application from this location. So pod.yaml. So this application deploy into my cluster. Enter. In my cluster, in my worker nodes, I am creating the pod node app created. Pods are created. In the pods, application will be run. After creating pods, you can test the verification command. This is the command to test your pods. See kubectl get pods. Kubectl get nodes, get pods. Simple commands. You want to check the node kubectl get nodes. In the nodes, pods are created or not. Check the kubectl get pods. In nodes, pods are created. See, in nodes, one pod is created. One pod is running. Right. So once creating pod, next you can use this all the command. Describe the pod information. What is that pod? What is that application information? That is container information. This is command to check the information that are running application information. See, kubectl describe. So I created cluster. I created worker node group. In that node group, I created one pod application. My pod application is running inside the pod. So pod is nothing but container. Inside container. So this is application I am running. So this is the IP address information. Okay. and then Docker image in the pod contain this is the Node app. This Node app contain this container images. This is the application image, real-time application. Yeah, this is the container image ID. The place is taken. This is information about the pod information. What is the information? What type of application it is running? So everything is successful. It is running on a sample application. So you can see you can expose that to public access also. You can see execute the command on pods. You can execute this command as well as all pod commands are there here. You can try one by one all these commands. Shared guide also is there. You can use that sample nginx, Apache 2. You can use that container also. You can use any containers. So example MC. This is the kubectl execute node app in print review, print environment. So this application is successfully up running and working. Next to command, yeah, getting into pod terminal. Yeah, you can go this command, you can get pod terminal. Yeah, next to exposing pods to or internet. So public, I mean, customer want to access your website or your application. So this is command, you can expose the your application also. kubectl node pod. Here you can enter your application name. Node app type. So by default, pods are running in isolated environment. They are chargeable within the Kubernetes cluster. If you want to run pods outside the cluster, you have to expose it. So we can expose by using this command. Use this command, you can expose also. kubectl expose pod node app type node port. Service node app is exposed, right? So after exposing, outside people also you access your website. So by using the IP address, this IP address, this is the information, this IP address. So click on the link, they can able to expose. Okay, see, I created a cluster with nodes apps. In the particular nodes, I deployed my application also. These nodes are running my application. You click on any node. See, so this is the node information, Kubernetes version information. You can see. Yes, AWS node proxy, everything is enabled. So in this, we deployed the pod also, Linux machine. In this Linux machine, my node application is running. Everything is fine here. There is no error message. So nodes are running, kubectl proxy is running. Yeah. T2 micro instant is running, node group is there. Everything's fine. So status should be green and active. You can go per cluster. You can open the cluster. So details of the cluster. This is auto scaling group. IAM role information, size of your cluster, max of 4 nodes. Nodes C. This is node information. Everything's fine. Health issues, yeah, active. Everything's fine. Click on cluster. So like this, first you have to create the cluster. You have to create the worker nodes, and you can deploy the any applications. Yes, this is format cluster. See, workload information, yeah. So 2 ready, yeah. So 4 ready. So my kubectl with 4 nodes are running. 19 minutes ago, so just AWS node. See, this is my node information. Yes, everything is running. There is no issue at any place. I verified all the information. And also your system also, you can check system side. You can check the comments verification. Less comments. See, go to kubectl, cd space ctl. So cd space ctl. It's not a direct file, I think. Okay, cat space kubectl. So sorry, that's wrong comment. You can check the file information of ls. So cat space. This is executable file. Yeah, this is the information in the your kubectl. So you can find all the information. So this is the file allowed to connect to your cluster. So it is running the node group. It is running the parts. Everything is success. Control C. Just Control D. Log out. Okay, like that you can test also, debug also. Everything is fine. Clear. So like this, create a cluster, create the worker nodes, and deploy the sample application. At time of deploying, you can take any repository. So like this, I deploy this application. Instead of this application, you can enter here nginx. Okay, so you can just enter the nginx also. You can deploy. It's not only this one. You can replace. You can give the nginx. Last time I shared guide, right? In the guide also it is there. Yeah, in the guide we have some reference videos also we attached to. You can follow that information as well. kubectl. kubectl. Yes. So this guide, the total. This is complete on only Kubernetes. Is complete information on Kubernetes. So if you are want expert in Kubernetes, only this is topics comes under. This is special topic for only Kubernetes. Now you can see how to deploy your application. This is the architecture. This is very important. Most of the interview time they will ask the Kubernetes architecture. Now you can see in this architecture, master node, work nodes. So what you did same, right? So see, this is architecture. See, master means manage, plan, schedule, monitor the node. Master is nothing but our cluster. So cluster is called the master node. In the cluster, we have these four components: etcd cluster, kube API server, kube control manager, kube scheduler. You need to remember these four components. They will ask into question: what is the how many components are available in the master node? Master node will have the four components. These four components are used to control the worker nodes. So these are four components: kube API server, and kube scheduler is there, kube control manager is there, etcd cluster is there. These four components came below, description is there. You can check it one by one. What is the definition of these four components? And then coming to worker nodes means node group. Just now we create one node group, right? For ECD instance. This is the worker nodes. Worker nodes host applications as a container. Host means you can deploy, you can run your project as a container. So applications as a container. You can deploy any of your Docker containers. You can deploy any nginx container, Ubuntu container, Apple container, Apache container, any container you can deploy into your worker nodes. So in the worker nodes, majorly two components are there: kube-led component, kube proxy. These are the components. See, you can deploy, you can run the worker nodes. You can deploy Docker images and RKT images. You can deploy. So these are the components of the worker nodes: kube-led, kube proxy. These are the cluster components. These are the worker group components. This is the main architecture of the Kubernetes. Very important. So see below you can see the control. What is control panel description? What is the ECD? We will store the key value information. Okay, kube scheduler. What is job of the kube scheduler? And then control manager job. Now you can see some reference documents. If you click on these links, clearly you get the information about the complete information about the kubectl, so that you will have an idea. So in the Kubernetes, we have the pods, deployment to services, to namespace. So we are using the YAML Python language. Based on YAML is based on Python. Static pods, dominant sets. They are all used. This is container. See what is container? Baby computer inside of a computer. Container is nothing but it's maybe any applet Python setup in the application. So it look like so Python Alpine worker. This is syntax to deploy the container. Yeah, so this is the Kubernetes pod information. Pod is nothing but a sample, small, latest, smallest application running in your worker nodes. So these are deployments, services. So this is the syntax for YAML means yet another markup language. This is the syntax in YAML language. You can scripting that you can see the four components. API version is mandatory, kind is mandatory, metadata is mandatory, specification is mandatory. Namespace means your name of your cluster. Yeah, see this pod, how to deploy pods. So just now we deploy, right? kubectl run nginx image nginx. You can run this one, and you can use this command also. kubectl create -f nginx.yaml. Okay, so if you have the YAML file in your location, so you can run that YAML in your cluster. So you take the YAML image container, you can run it also. This command also you can use. You can use your cluster also. Sample, go for your cluster management. Go for instant connect. Yeah, like that you can deploy any container in your cluster. So this is the last 2 to 3 years. So most of the organization, they are using the cluster management. They are selecting for Kubernetes only. Before there we have mess one as some other softwares also there. They prefer recently they prefer everyone is selecting the Kubernetes only. Most of the organization, they are running this one. See, so I am running the kubectl. The file we need to here list. We need to create the yam nginx file, and then after getting the file, you can kubectl come. You can use it. Okay, right. And I mean YAML file. This file contain the nginx container information. Right? Yeah, like that. See. So this is the complete information about the components. So if you should export in Kubernetes, you need to follow the complete information. Yeah, so this is very important. So you can expose kubectl create services, kubectl expose pod validate to via some particular port number. You can expose. So expose means you can access public outside people access your services by using the particular work port, multiple ports. They are the complete information about the Kubernetes. Please don't share this document anyone. This is the, I think this name is, my organization name is there. That is reason. So yeah, origin study group is there. That is reason. I not remove this one. Okay, no problem. Right, coming to back. So this is the cluster management in EKS and ECS. These are the 4 very important components. I can re-verify it to what are these topics. Elastic container registries, pressures. You can push this command. You can put this concept in resume. ECR. What is ECR? What is EKS, ECS, Elastic Container Services? What is EKS, Elastic Kubernetes Service, and forget. That's why we discussed, right? Forget. Yeah, these 4 components are very important. Before the Docker also very important. Docker, Kubernetes, forget. Next, you go for the Terraform. So I will show you what is Terraform. So yeah. Log into your dashboard, you can run the Terraform script. So this is Mumbai location, right? Go for Mumbai location, go for your EC2 instance. Yeah. So for Terraform, you can run your Linux computer. So this machine, you can install the Terraform and you can run. Otherwise, you can directly see lightweight Linux virtual machine is there in your location. See, this is my lightweight virtual machine, Cloud Shell. So I will show you how to use Cloud Shell also. Click on Cloud Shell. By using the Cloud Shell also, you can run the Terraform. What is Terraform? Terraform is nothing but it is a configuration provisioning tool. So as of now, we are creating all the instance, so Linux instance, Windows instance, so manually, graphically, right? Via script automation, how to do automation by using the automation way, how to launch your resources, how to provisioning your resources. Resource means whatever maybe it may be EC2 instance, or DB instance, database instance, or a web server, or Linux server, or Windows server, whatever maybe, or networking, or VPC, load balancer. So you can launch any, you can provision any resource, any service in the AWS dashboard by using the Terraform script. I will show you how to run this Terraform script. I said first you need to log into your dashboard and click on Cloud Shell. My Cloud Shell, I started my region is the Mumbai region. Region is the AP South one. Now open your Cloud Shell. After Cloud Shell open, so you can test the Terraform script. Yeah, so this is the way Cloud Shell does. Cloud Shell is nothing but lightweight Linux virtual machine. See, your terminal is there. So you can enter all the Linux command here. Present working directory. Who am I? So user, Cloud Shell user. Okay, so LL, all directories are there. Some directories are there. Okay, no problem. So see, so here Terraform installer net. So first check the Terraform installer. How to check the Terraform installer? What is command? Terraform space hyphen version. Terraform hyphen version. Now see, there is no Terraform install. Terraform hyphen version. Here there is no Terraform install. Now how to install the Terraform in your Linux computer? So we have commands. Just click on Terraform installation. Just click on here. So you have documentation. So Terraform installation in Linux. Yeah, you can go for this is direct to Terraform website, terraform.io. So Terraform is provided by the HashiCorp organization. So they are implemented this Terraform software. Now this is the get started with the Terraform. So log into Terraform. See, but I want to install the Terraform in my Linux computer. So command is Terraform installing Cloud Shell, AWS Cloud Shell. So just enter this command. So it will give you some commands. Terraform installation. Yeah. AWS Cloud Shell and Terraform. So this is command to install the Terraform your AWS. Now copy this command wget get wget, copy this command and downloading the my Terraform software to my Cloud Shell. Copy paste. Oh, double times. Wget. Yes, enter. See, Terraform is downloaded. Yeah, sudo yes. Next command. Oh, this is the complete command. Otherwise, the entire comments. Yeah. Copy paste. Enter into Cloud Shell. Yeah, paste. See, Terraform was successfully downloaded. Now just verify Terraform install or not. Check the version. Hyphen. It's not installed. Enter this command one by one. First, this is command. First, download the software. Okay, after downloading software, and then unzip software. Yes, this is the command to unzip. Unzip it. Yeah, after unzipping, so see Terraform yes, replace Terraform yes, yes, yes. Let's see Terraform install. Terraform is downloaded, right? Next, after downloading Terraform, next command, make directory, move the Terraform to bin directory. Cloud Shell. Yes. File already exists. Okay. Next one, move Terraform to bin directory. I think already we moved. So enter this command. Yeah. So this is process. Yeah. Next, enter the Terraform version. Terraform space hyphen. See, Terraform version 0.14.4 installed successfully, right? Like that, you need to first install the Terraform in your Cloud Shell or your Linux machine or Windows machine. Once installing the Terraform software in your Cloud Shell, your Linux computer or Windows computer, next, how to run that to Terraform? First, you need to authenticate to your AWS dashboard. How to authenticate AWS dashboard? AWS hyphen version 2 install or not? AWS CLI is installed or not? See, check it. AWS CLI is successfully installed. Now authenticate to your dashboard by using the AWS CLI. AWS CONFIGUR configure. You know, right? How to authenticate? Go for, so it is in Mumbai region, right? We are at Mumbai region. Now go for IAM credential. Generate the select Mumbai region. States. Generate the root user access key and private key and enter it. After that, you can enter this Terraform script. Yeah, so Mumbai region. Now go for security credential. Click on my security credential. Just generate the access key, secret key for your root account, or you can create IAM user account and generate access key. That one also you can use for authentication purpose. See, from Cloud Shell, I am connected to my AWS dashboard. So expand this one. Yes, already I have delete one and again recreate. Maximum 2 keys we can generate. So these keys are generated for other domain. Yes. So copy this one, paste here. I'm deleting one. I'm regenerating again. access key. Okay, see in region, which region you are generating, so that is important. Create I want per this access key per Mumbai region, right? Create new access key. This is my new access key. Okay, enter this access key. Just a minute. Copy this one and enter into your cloud shell, right? Copy paste here, same last time you already did. Again go for next to secret key. This will give authentication to, so you cloud shell user able to log into your AWS dashboard in Mumbai region. AP Southward correct, JSON parameter is correct, successfully created. Now here you can close this one. You can download this credentials also required. See, so after refresh, enable. Yes, to refresh it will activate it. Access key, secret key actually activated. So region last update it will not get activated, it will activate it, right? So once login, now you need to run the Terraform script. So ls, is there any Terraform files? No, you can run the new Terraform files. So let's see, I ran some Terraform files. So cd space demo, is there any Terraform file? ls sample.tf file there, cat space check that what is file in that sample. See, sample.tf file. See, this is the just to create the, okay, it is the syntax to create the one Linux mission computer, one system. So copy this syntax. Yes, this is syntax to create the system. Copy this one, copy paste your notepad. I will show you how to create one Linux mission or one virtual machine in your via Terraform script, via automation instead of manual. How to create the, how to launch the, what to provision the virtual machine. See, provided AWS profile default AP South one region instance name. This is the AMI image. So this image we need to select. So this image where you can select, go for your AWS dashboard, select to any region. So I want this image. So this is right. You can select to, you want to create a same like a same Linux machine. Yeah, take this image, go for action step. Okay, so instance image, create image. Yeah, so this is the test image name, test image, test image, create. I just create one image. So this is the place you can see your image. By using the image ID, you can generate the virtual machine. You can via Terraform script. So test image, right? Copy this image ID. Just copy. Yeah, go under image ID came. It's not at copied. So I want image name. It's not at came. So once it's activated, it came. Right, take any image, it will automatically generate. So there are already some images there, so you can take any image. So this image I want to take, copy AMI or modify, copy AMI. Yeah, I am taking example, I am taking this image. So this system will be created automatically. See, go on to copy paste which Linux machine you want, same machine it will generate here, image ID. Now enter, execute this command. This is the Terraform script, automation script, right? Go for your cloud shell, ls cd space dot create a new directory. You are running your own file, right? So create one mkdir so ikk directory, no space. Okay, go for cd space demo. I will remove that file. ls cd space rm cmp sample .tf. I am removing this file. Yes, ls not at remote. So sudo rm cam .tf. See, file is removed. So I am creating my own file. So how to create file? You can use the cat command to create file. You can use the touch command to create the file, and you can use the vim command, vi command, or nano command. These are the commands to create your file. So let me vi space vm.tf. Extension should be tf. This is the Terraform script, right? vm.tf. So it will open file. Insert mode, copy paste your syntax. Okay, paste. This is my syntax. Terraform script. Escape. Save the wq. Yeah, click on escape. Save the file. wq shift 1. Okay, sorry, it's not saved. Escape. Insert mode. Okay, escape. wq shift 1. Okay, we need permissions, right? Okay, escape to sudo. We need to enter sudo command. Sudo vm.tf. ls vm already created. Sudo rm vm.tf. Yeah, right. Create the file. Sudo vm vi space vm.tf file. Okay, enter your syntax. Copy paste. Okay, now escape, save the file, wq shift 1. That file is saved. So now I want to execute the Terraform script. So what is command to execute Terraform? Yeah, first Terraform initiate the Terraform. We have hardly 4 commands. I will show you how to. So what is our instance? So we enter Terraform. This is your instance will be created. Example apps, or this is your instance name. This instance will be created. So okay, let me enter Terraform. First command initiate. Now if code is correct, Terraform initiated correctly. If code is wrong, it will not initiate it. See, file instant provider is file. No space left on the device. Okay. Oh, space is not there. Let's see. Go for cd dot. I want to remove some of the. Okay. Sudo rm dir. I will remove some of the file. But it's not empty. Okay, I want to remove some of the directories. cd space. So cd space sudo rm main that space is not there. I'm removing some of the files. Okay, ls cd space remove sudo rm remove ls cd space sudo rm enter this zip file. I want to remove. I'm praying already space is occupied. Okay. Copy this command. Paste here. See. ls. See remove. Okay. cd space dot. Just remove the data current directory. Sudo space rmdir current. See ls. So now try to create a cd go for your directory ls cd space demo. Now in this demo directory I have my file, right? Now I am running the Terraform script here, so you can run now. So Terraform space initiate. If code is correct, Terraform file initiated successfully. See, Terraform has successfully initiated. After Terraform initiate, next command is Terraform validate. Code validate. Now it's validated your code. Terraform validate. Yeah, success. It should come like this. Success. Terraform configuration file is validated. Next command Terraform plan. See, in plan it will display as per your script. What are the things you need to modify? What are the resources you need to create? In my script, I have mentioned one task, so need to create a virtual machine. Okay, that task will run. Next command Terraform apply. It will apply your action plan done. It will launch your virtual machine via automation. We do enter yes. Yeah, it will launch your start creating, including source, invalid AMD. AMI is invalid. Okay. AWS app service, okay. This image is invalid. Now take at that image. I think that image we are taken from other location. Okay. Select our recently created VM. Copy paste this one. Copy IMS. This image, right? Copy this image. Yeah. Now go for your location. Just modify the file. ls vi sudo vi space vm dot tf. Okay. What is the file? Better to remove all this file. Some state is executed. Escape colon q shift 1. So create ls rm sudo rm terraform dot. I am removing this file again. I will rerun tf state. Yeah. Okay. Now just rerun again. Sudo space vi space vm dot tf. Okay. Now what we have to do? Why is same file came here? Instead of deleting entire file, space dot dot cd space mkdir dir cd space test. Create your file. Just copy that your recently generated image id. So it is taking wrong image id. That is it's not created. Yeah. This is my image id. Space is there. Yes. Okay. Now copy this syntax and copy paste here. Create new file. Sudo space vi space vm dot tf. Extension must be tf. Your script extension. Copy paste. Yes. Paste. Right. So instant type to that micro. Escape. Save the file. WQ shift 1. We have to enter 4 commands. First command Terraform initiate init initiate. It is initiating Terraform. Right. It is showing some error. What is some error? Registration Terraform space only space problem. So I already did some other files. Okay. Cd space dot dot ls. Okay. Cd space go for demo. One file ls some remove some file. Sudo rm terraform dot tf state c ls remove cd space dot dot remove the directory also. Sudo rm directory name demo 1. Yes, cd space demo 1. Yeah, cd space dot dot. So directory name demo 1. Not empty. This is already empty, right? Okay, so now go for our directory cd space just this. Yeah. Now run the command from initiate. CS problem. Actually, I have created number of the files here, like remove. So space Demo is not empty. CD space. Yeah, it's already empty. CD space dot dot space new demo. So yeah, test.tf. Yes, yeah, dot dot. I'm deleting some directories to clean the space. RMDIR. For your, you don't have this issue. So this is not MB directory, RM directory. Sudo directory. Like, let me delete file. File name. This file name I want to delete. Right. CD space sudo RM. Let me remove some other files also so that it will clean this some space. This is trial account, right? A little bit size will be less in Cloud Shell. So we need to execute one by one. Yeah, go for your directory CD space test ls. Yeah, Terraform share. While Terraform visited there is no space left on the device. Still no space. Let me remove. Started. Sudo remove. I'm removing this file as well as. Yes. Now check the what is file is correct or not. All right. Yeah, yeah. Okay. So create the sudo. Yeah. VA space VM.tf. Now enter your code. Sample script. Okay. Any spaces are there? Yeah, everything is fine. Okay. Paste. Right. Okay. Escape. Colon WQ. Shift 1. Okay. Terraform. So VM.tf. There is no file, so let me create a sudo VS space VM.main.tf. Okay. Yeah, copy paste this syntax. Paste here. Paste. Escape. Save the file. WQ shift 1. Clear ls. Right. Run the Terraform script. No space. Still no space. Why is this reason? Like that. So you go for any other file. CD space new. So vi space yeah. So enter this here. So paste escape colon w shift 1. Right. Let's now run the Terraform script. While installing RScope version mkdir Terraform massive gap, no space left on GWise. Okay, so no problem. So you have to enter these 4 commands. You can remember. So once this copy paste, I will give the syntax. Okay, just enter the 4 commands. I will ping in chat. In your system, it will run. So my system has space issues. I will ping in chat. You can try. Yeah. So this is the Terraform script. Yeah. So copy paste your notepad. So commands you need to enter. First you need to enter Terraform initiate. This is first command. Sorry, spelling wrong. Terraform initiate. Okay. After Terraform initiate, next command is the validate. Is the next command. Next command Terraform plan. Next command Terraform apply. So after entering apply, instant will be created. Go on the instant dashboard and check instance is created or not. Now you want to destroy the instant. This is command. At the end, you have to enter this command. Destroy.
I think your screen is stopped. I mean, I can't hear your screen, Kiran Garu.
Okay, let me share. Yeah.
Yes, sir, not moving.
Okay, now you are able to see.
No, I can see your notepad or not.
Yeah, notepad on I'm pinging. See, in my system, my device, this space problem is there. That is
Okay.
it. So in notepad, I just share the details. You enter the same details. In your system, it's to work out. See this his 4 command you need to enter. Terraform initiate, Terraform this 4 command, validate, plan, apply, destroy. So it will execute in your computer. Right? Same process. Just create one directory and copy paste in that directory. Copy paste the file. So create one directory and then enter this file. Yeah, like this. Create use command sudo space vi space main.tf like this. Enter this command and copy paste your this syntax and save the file and run this 5 commands one by one. Simple. So it will execute it. It will run your dashboard. W shift 1. So try. If you have any errors, I will show tomorrow. Clear?
Yeah, sure.
I will share the this recording for your purpose. So first of the 4 concepts you need to do. So ECR, ECS, EKS, or forget. After finishing those practicals and come to the Terraform practicals.